The Western Canadian Sedimentary Basin holds an estimated 170 billion barrels of recoverable oil reserves. Most of those barrels, about 95%, are unconventional reserves contained within the Alberta oil sands. But what exactly do we mean by the term unconventional? Unconventional oil is defined as any oil that's embedded in a rock formation and doesn't flow under normal conditions. In other words, it can't just be pumped out of the ground like conventional oil. Conventional oil is typically contained within a pressurized reservoir located in pockets deep underground, trapped by an overlying rock formation with low permeability. A well is drilled into the reservoir, allowing the oil to flow up to the surface. Unconventional oil deposits are not found in discrete pools, but instead are spread out over a larger area. The oil is embedded within a rock, typically a shale or a sandstone. If you were to drill into that rock, nothing would come out. Let's look at two very different unconventional formations: the Eagle Ford Shale in southern Texas and the McMurray Formation, which is contained in the Athabasca oil sands. Both are unconventional oil deposits, but for very different reasons. The Eagle Ford Shale Formation is located several kilometers below the ground, where the temperatures are around 120 degrees Celsius, and reservoir pressures are very high, typically about 45,000 kPa. The McMurray Formation is actually very shallow, averaging about 350 meters below grade, and since it's closer to the surface, reservoir temperatures are also a lot cooler, typically around 7 degrees C, and reservoir pressures are also very low, typically less than 1,000 kPa. So those are three very big differences between the two deposits. Now let's take a look at the two different rock formations. The Eagle Ford Shale is actually a mix of shale and carbonates, so it's a very tight formation. Porosity is only about 10%, and permeability is very poor, almost zero, which means those pore spaces are not very well connected. The McMurray Formation is a loose sandstone with a small amount of fine clays. Porosity is much higher, as high as 35%, and those pore spaces are very well connected, so very high permeability. So these are two very different rock formations. Now let's take a look at the oil contained in that rock. Eagle Ford contains a very light oil, and since the formation is relatively warm, the oil has a very low viscosity and therefore flows very easily. Oil in the McMurray Formation is in the form of bitumen, which is an extra heavy oil, and the reservoir is also a lot cooler, which means viscosity is off the charts. Bitumen is almost solid at low temperatures, so it's definitely not moving anywhere. That leaves us with two very different problems. In the Eagle Ford, we have a very light, mobile oil, but the rock is completely impermeable, so that oil is trapped. In the oil sands, the sandstone is very permeable and very porous, but the bitumen is too cold to flow. So how do we extract oil from these unconventional deposits? In the Eagle Ford case, we have to improve the permeability of the shale. Producers will drill a horizontal well along the length of the formation, then use explosives to punch holes through the rock. A very high-pressure mixture of water, sand, and additives are pumped into the voids, creating tiny microfractures throughout the formation. The sand particles become embedded in these fractures, keeping the void spaces open, which allows for the oil and water to flow towards the production well and be collected at the surface. This process is known as hydraulic fracturing. Now let's go back to the oil sands. Again, we have a very porous, very permeable sand matrix in the McMurray Formation, so no need to fracture the rock. But the reservoir is very cold, which means the bitumen is not mobile. To get around this problem, we need to bring the reservoir temperature to about 200 degrees Celsius. And why 200? Well, because it lowers the bitumen viscosity to the point where it's liquid enough to flow. To heat the reservoir, steam is injected into the targeted formation at relatively low pressures since the sand is very permeable. As the bitumen warms up, it begins to flow by gravity to a production well stacked below the steam injection well, leaving all the sand in place. This process is known as steam-assisted gravity drainage. Combined, Canada and the US produced about 17.5 million barrels per day of crude oil in 2023, and 2/3 of that oil came from unconventional deposits, like tight oil from shale and carbonate reservoirs in places like Texas and North Dakota, and bitumen from the oil sands near Cold Lake and in the Athabasca area. So unconventional oil extraction is an essential part of North America's energy security. I hope you enjoyed this video. Thanks for watching, and we'll see you in the next one. Bye for now.